I am Bowie, and I'll be talking about actually our work in asynchronous communication in general, and then specifically some of our projects that are going on right now in the Philippines and the Senegal. This is a collaboration with Cedric Festin and Hassan. So when we started our research group TIER, we saw that there were many applications which could have a great benefit and use in ICT for D. For example, in the area of education, a lot of groups we found were taking, say, snapshots of Wikipedia and distributing them, or trying to figure out some way to use this material for distance learning. In the area of healthcare, we found that there was a lot of demand for some kind of electronic patient medical record system. And in general, in the terms of collaboration applications, there was a lot of demand for, say, shared whiteboard or discussion groups. Now, when we look at communications in developing regions, we find that limited infrastructure forces us to redefine what we think of as networking and connectivity. For example, we cannot just think of a connection to the internet. We may have instead a local intranet which is well connected while we are not connected to the wider internet. For example, in the TIER Aravind wireless deployment, the hospitals amongst each other are very well connected with the wireless network, but they may not have a connection to the wider internet. Also, we can think of communications not just in terms of standard network communications, but more esoteric things such as SneakerNet, which is taking a USB key, plugging it into one computer, and then synchronizing it with another computer. Finally, there's, say, a widespread deployment of mobile technology, which presents yet another form of communications, SMS and GPRS in general. And finally, connectivity, as we saw in the previous project and in Rowena's talk, if you were here yesterday, can be intermittent and very heterogeneous. So how do we take these technologies and use them to support the applications I mentioned before? So many existing applications have been built with assuming always online connectivity. So in a lot of these applications, say Wikipedia, OpenMRS, they're built assuming that you'll put a web server somewhere and then people will access it using the internet. However, the application usage model doesn't always require this. For example, email, which is an application we all know, doesn't require us to be always connected to the internet to be used. And same thing with SMS and voicemail, as Curtis just mentioned. However, on the other side, there are some applications which do require this. And our argument is that a lot of these applications that are useful will lie in the more asynchronous side of the spectrum. So to give a very high-level view of what our research group has done over the last 5 years is we looked at two basic arms in our research. First is, how do we use this heterogeneous and intermittent communications network as a coherent, cohesive network to program to? And this is the province of our research in delay-tolerant networking. The second question is, we have a lot of applications that already exist. For example, IMAP email services, the Wikipedia services, and OpenMRS. And how do we make it easy to, say, build these applications or port these applications to be used on top of a delay-tolerant network? And this is the work that we've been doing on TierStore, which is a distributed file system for building applications on delay-tolerant networks, and TierDB, which is a simple distributed database for DTNs. Now, the thing to really, this is a very high-level overview, because I don't have enough time, but the thing to really think about TierStore and TierDB is it's a sink for different file systems and databases. So you take your application, you deploy it on various computers in your network, and they may be intermittently connected to each other, but you use our TierStore or TierDB software to synchronize the data among them. And because we have delay-tolerant networking, we need to think about, say, cost and time. For example, sending an SMS costs some amount of money, and connecting to the internet costs some amount of money, and we need to think about the user's data and how much they're willing to pay for the connection and how much delays they're willing to tolerate. So both of these systems have a way of having the user say what their priorities are and how to schedule their transmissions. Also, because we're asynchronous in that two computers can do updates to their database at the same time while they're not connected to each other and while not knowing each other, and these updates might conflict with each other. For example, if a doctor is editing a medical record in one health center and another doctor is editing the same record in another health center, so there needs to be some mechanism for handling these concurrent updates, and this is handled by the system. And finally, there needs to be ease of development. So each of these systems is a very thin layer on top of existing ways that applications store their data. For example, in TierStore, it's a file system. In TierDB, it's a database. So this allows very easy porting for, say, existing applications such as Wikipedia or email systems on top of the asynchronous communications. So I want to kind of give you, that was a very high-level overview of what the system does, and I want to kind of give you a sense, using our projects as an example of what the system can do. So in the Philippines, there was this system, which is a medical record system called the Community Health Information Tracking System. And this was built by a group headed by a doctor in the Philippines at the University of Philippines. And what it does is, before in the medical record system in their health centers, what they would do is when a patient comes, they would write an entry in their logbook, and then that would just be filed away. And this was extremely error-prone and basically unsearchable. So it made the records that they stored in the health centers almost unusable. And what the CHITS health system did is they replaced that with a internet-based web application in which they could enter the data and then search for things. So this was deployed in 18 health centers, and it was written as an internet web app on top of SQL and so forth. And this is what it looks like. You can see that this is the patient record and various modules associated with various Department of Health programs such as vaccinations and so forth. And this stores the patient records. Now, this is all very good. They were able to search within the health center for their patient records, but it still had a few problems. Because the application only ran within each health center, none of the health centers are linked together in any way. So in terms of final data collection, in which they pull all the records to the central facility, for example, to collect statistics, this all had to be done by site visits from the staff. The staff would go to a health center, pull the data, and then finally collect it by hand. Also, if you think about in terms of patient mobility, a patient may live in one district, work in another district, and yet prefer to go to a health center in a third district. And he may visit health centers in all three districts. Well, patient mobility results in duplicate and inaccurate records. And there's some anecdotal evidence that patients actually perform some kind of fraud, some of them by going to health centers multiple times, different health centers, and collecting free drugs and so forth. And this is compounded by the fact that the Philippines has no universal identification system. So, and also, third problem with the existing CHITS system is that there's no mechanism for patient referral. When a patient needs to be referred, essentially, since there's no communication between the centers, you print out a patient record, you give it to the patient, and the patient has to do the referral himself. So that's very error-prone because the patient is prone to lose the medical record, and also when the patient is done with his referral, the medical record does not come back to the original home site of the patient. So essentially, right now, the existing status quo is that there are these health centers, but they essentially run independently of each other, a copy of the CHITS system. And what we're trying to do with TierDB is link them with the various communication mechanisms that are available. And if you note that, say, between Pasay and Manila, we have to use SMS or GPRS, because that's the only thing that's available. While in Marikina, we could use SMS or a dial-up modem. So kind of some of the interesting operating constraints that we have to deal with in a TierDB system is that each health center has a very low communications budget, about $20 a month. So we've been trying to play with what data we should send in order to keep it under $20 a month. Also, we have to adapt to various forms of communications. For example, we saw before, the slide before, that the center has available, each center has different kinds of communications available, and we would like to develop a single system for all the centers. Also, data has different priorities. For example, we were talking to the doctors, and they said that, oh, new patient records need to be synchronized by the end of the day, but everything else really only requires a weekly or monthly report. So we have been building that into the system that we're going to test. So in terms of the current status, I'm actually flying out today to do a site visit for the next 2 weeks. And we're going to test the viability of using our TierDB system for synchronizing to test the viability of various types of communications. And then we're building a prototype and test deployment in around February 2009. Also, the other project that we've been looking at is a bunch of schools in Senegal with around 700 students. And the problem here is, again, there's no existing medical record system, and what happens is visiting doctors visit the school, they do checkups on the students, and then when the student goes to the hospital, they annotate the records. And right now there's no flow of records between the hospitals and the schools. And what I've been working with in Asan and the undergrad is to try to build a very simple synchronized medical record system between the schools and the hospital. And for more information, we're actually open sourcing the synchronization software, and I'm actually looking for other projects kind of drive the development and test our framework. So.
Question?
Lakshmi.
One of them.
I don't need the mic, actually.
Actually, one of my students is in South Africa right now, working on a cell phone-based database for health records using SMS and GPRS, very, very similar flavor. Maybe if you guys have something that can be piloted even in South Africa, that's a possibility.
Yeah, I'm looking for as many projects as possible.
So in terms of the technical difference in the take is that if you have a very generic database which supports a whole range of queries, then it's much harder to optimize for every bit that you send. On the other hand, if you constrain the set of queries, then you can actually semantically compress for every bit that you transmit. For example, if you're doing a patient update and if you know the schema, you can set the fifth bit to be 0 or 1 and you know what the fifth bit is. So if you restrict your schema, what we have found in our little experiences, you can actually get much better semantic compression.
So what I didn't have time to go into in detail is that we actually have a mechanism for identifying application-specific compression. For instance, you want your queries to fit in the 160-character SMS, right? You don't want to split it up multiple SMS. So given the programmer has to make a description of the kinds of queries that the system will answer, but given that, you can write your application-specific compression, which is what you're mentioning.
Okay.
Other questions?
I'm curious as to how you choose between the different communications technologies. You didn't really go into detail about that, and if you could say a couple words.
So at least in the Philippines, what we found is that the choice is fairly easy in that basically new patient records should be sent immediately on SMS, because that's what the doctors want. And then the rest of the bulk updates can be done in a slower offline, perhaps even with site visits for synchronization. There is room for smarter scheduling, but we haven't seen the need, at least right now, for anything like that.
before I give Kevin the mic, I should say that Kevin has led a lot of the DTN efforts, and we've benefited a lot from his guidance.
So you can probably understand my next question, which is, so you mentioned these other projects. There was work on DTN, and there's TierStore, there's this. Can you kind of tell us the evolution here? What's changed? What's the same? What's the future? In terms of architecture inside and compatibility with the existing work that had been done before?
Okay, so DTN is a network overlay, which essentially abstracts different various network communications. So what that means is you have, let's say you have SMS, GPRS, internet, and satellite, and DTN allows you to write a network application which uses all of them without having to really know how to communicate with each individual technology. And also is a store and forward network in that if you ever have a disconnection, it'll store your packets and then send them when the connection is available. Finally, DTN does all sorts of nifty stuff with routing in terms of routing around disconnections and so forth. So we saw that DTN was really useful for some basic applications such as sending voicemail, but when we went to build, say, some more complicated applications such as wikis or an email system, we found that the application programmer kind of needs a higher level interface. So then we went and built TierStore, which works on top of DTN, which offers a shared file system interface that the programmer can interact with and doesn't have to worry about dealing with DTN. And then after we built TierStore, we've been trying to port other applications to TierStore, and we found that a lot of applications are built using this sort of web app-based framework in which we have some kind of application code and then a SQL database, and then that was the way to build it. So then sort of TierDB is to extend the TierStore architecture onto a simplified database. So it does use some aspects of DTN for the communications.
Is it wire compatible?
No, so what TierDB eventually will have is use DTN as communications, as one of the ways it can do communications.
Okay. The point, so I have another hat on here, which is the research to the DTN. There's a DTN research group out in the world. If you're interested, it's dtnrg.org. And since you're pushing on some of the higher level applications, which is in some ways more than some of the other people in that group have been pushing on, I have a biased interest to make sure that work is compatible and supportive of, I think, what you want to do. So I'm interested in furthering that.
We had one more question down here. Move on.
Have you had any trouble with connectivity dying in the middle of a sync? And how do you deal with partial data transmission?
So all of our protocols are kind of constructed in a way that dying in the middle of a sync doesn't affect it. And if you're working with DTN, actually DTN handles partial transfers and reinitializing the transfer and so forth. So actually it's handled in the DTN layer. And then our protocols don't rely on this connection between nodes.
Great, thank you so much.